everyone. I hope we are live. And now I'm going to actually, solve lead code problem, which is find the number of ways to place people. It is the second version of the problem. I think the first version is a medium one. That also I haven't solved it. So I will be attempting this hard problem. So those who are new to this channel is all about logic building, uh, logic building of lead code problems. And here I will be building the solution for this problem from scratch. I'll be reading the problem in front of you, and basically I will be showing you how to approach things. This might not make sense for a lot of you because it is going to be a long video, but that said, I'm doing it for myself. I'm not doing for anybody else. If I had to create a tutorial videos, I could have easily solved it or checked solutions and solved it, and then I could go live and solve it in within 12 minutes. But that's not the way we could operate. Basically here I'll be solving it from scratch. I haven't seen this problem before, and this is a new idea of me, but I haven't solved this before. Okay, let's go ahead and check if we could solve it. I'll try my best to solve it, and sorry, I'm sure I'll be able to solve it. Okay. So the problem says find, so before any further, without any further ado, let me go to my iPad screen. I'll accept the request. Yes, go ahead. And here we go. Okay. Let me do one thing. So I think this is optimized. Okay, it has detected, my notability has detected it. Let me disable that. Yeah, I think this is much better. Maybe this is better. Yeah. Okay, so, but no, I don't like it. Let's keep it natural. Okay. So this is the screen, the actual screen which I have. Now I'll be solving it. So let's use a highlighter to first build a logic. First, read the problem. First step is reading. Okay, let me write it in a permanent marker. I will read and list down what is required. This is the first step. You are given a 2D array points of size. So the array is 2D of size n multiplied by 2 means n rows and 2 cells in each row, representing the integer coordinates of some points on a 2D plane. So I have been given what? I have been given points, which is a 2D array. And what do we have it here? So we have in each row we have the cells where we have xi and yi for the points that are there in a plane, okay, 2D plane, so on up till pn. So this is a n cross 2 sized array. We define right direction as positive x-axis, increasing x coordinate. So this is first info. Second info is right is positive x and left is probably negative y. Yes, negative y. Negative y. Similar, sorry, not negative y, it is decreasing x coordinate. So I have to make a correction over here. It is minus of x. And what about up and down? Okay, so there is up and down as well. Up is positive y, as I can see, and down is negative y. So nothing fancy, it is just the standard xy axis. So this is called right, this is called left, this is up, this is down. Okay, that's it. So this section is all about this definition of up, right, left, and top. Okay, so then you have to place n people including Alice and Bob. So we have to place n people including Alice and Bob or at these points such that there is exactly one person at every point. So we have to place n people at n points. Quite good because one at one point there will be one guy. And yeah, also there is written that there is exactly one person, so this was to specify at every point. Alice wants to be alone with Bob. Oh, nice. So Alice wants to be alone with Bob. Alice don't want Bob. Maybe that's the case. So Alice will build a rectangular fence with Alice's position. Okay. So if he doesn't want Bob to be there nearby him or her, whatever, so Alice is will build a rectangular fence with Alice position as the upper left corner. Okay, let me think. Upper left is this corner. So here there will be the Alice and Bob positioned as lower right corner. So this is our Bob. And what next? And as the lower right corner of the fence, right? Note that the fence might not enclose any area. It can be a line as well. What? Okay, but what's the case here? How to make sure that Alice wants to be alone with Bob? If any person other than Alice and Bob is either inside the fence or on the fence, Alice will be sad. Oh, I thought there was some breakup like situation, but it is a very good situation. So Alice wants to be alone with Bob means that Alice and Bob want some private space. Okay. So there is a fence which is defined by a rectangle where Alice is at this point and Bob is at this point, and this rectangle is there. And Alice says, yeah, if any person other than Alice and Bob is either inside the fence or on the fence, Alice will be sad. Return the number of pair of points. So that is also a requirement. Let me just write it. So there are two people which we have focus upon. One is Alice and one is Bob. So let's say these are their two coordinates. Now it can be anything like it currently I'm making it upside down, but it might happen that yeah, that also we need to think, right? Because if Bob is here and Alice is here, then it is not possible that so yeah, if even if we create the rectangle, okay, is it possible that this is the left side of the rectangle? If it is the left, upper left of the rectangle, it means that, what does it mean? So let's say sorry, Bob is here, Alice is here. But this case is a valid case because you see, Alice is at upper left, right, and Bob is at lower right. But if I create a rectangle here, you'll see that Alice is not at the top left and not at the, and again, Bob is also not at the top bottom right. So this is the case. Return the number of pair of points where you can place Alice and Bob such that Alice does not become sad on building the fence. Okay, so what I gathered from here is that this is an invalid position. So let's say if there are 2 point positions over these places, if we select these pairs as an ideal position for Alice and Bob, it is probably wrong. Why it is wrong? Because this is not forming a valid rectangle first of the at the first place. And now here there has to be isolation. Then only it will be a valid one. If there are more people inside this boundary or at the boundary, it will not allow them. So Alice will not feel, so these pair of points will not be the ideal ones. Okay, that's it. That's the problem. Note that Alice can build a fence with Alice position as upper left corner. Only build, yeah, that's what they have specified, which makes sense. That Alice can only build a fence with Alice position at upper left corner. Okay. Alice position should be upper left. Then only Alice, sorry, Alice can build the fence. And Bob position as the lower right corner. So Bob should be here, Alice should be here. That's what they have clearly specified. So, hmm, Alice cannot build the fences in the picture below with four corners as these. Why? Because, so they're talking about these first, and they will talk about these first. So this is the first case where they're saying that Alice position is not the upper left corner. Yeah, you can see Alice is at 3 3, so it is upper right, not upper left. Upper left is empty. So this is an invalid case. And Bob position is also not, sorry, Bob position is not the low right. Yeah, Bob has to be here, but it is here, so it is also not. This entire case is an invalid case. Also in this case as well, you can see that this part is invalid because this is this is in this case this is your bottom left, not bottom right. I mean lower left, not lower right. So these two cases are invalid. Other than that, many more cases like this. Okay, this is, yeah, this is a very interesting case. Let me write it in a permanent marker. So this case, let me use something like this. Yeah, so this case where, let me think of it, man. And there could be this case we have already discussed. So this was this case, which is an invalid. This is uh, also invalid. In, I mean, sorry, this is also invalid. What about this? If Alice is here, it means it is top right. I mean, it means it is upper right. So this will not work. What about this? So that's my doubt here. If we create a rectangle with these four vertices, so I think they have written something like rectangular fence. They have written something like line segment. I might have uh, read about it. Uh, yeah, that's the case. Note that the fence might not enclose any area. It can be a line. So this case it is valid because we can treat this as upper left, and this can be like lower right. But yeah, I need to check more cases. So I will be just opening Chrome and see what is there. Mhm. Okay, so this is the case, guys. Sorry. Sorry, my bad. So example 3, okay. Sorry. Alice at 1 3 and Bob at 1 1. What does that mean? 1 3 is here, Bob is here. Alice in 1 3, Bob at 1 1. This is a valid one. How it is possible? Okay, yeah. I get this point. So yeah, Alice is at top left. We can say that. Okay. This is a very good observation. Let me demonstrate that. So I thought it is just, so let me just write down all the cases so that it is easier for us to follow across. So first case, this diagonal and this diagonal. Now there are two cases here. So first case, what we do, we place Alice over here, Bob over here. This is accepted. Oh, sorry. Then the same case with Alice over here, Bob over here. So A cannot be upper and A cannot be, no matter whatever you do, A will be always, what can we say? It will be upper. No, it cannot be upper, it is lower because B is higher. So that makes, so what is required? Let me write over here. For A, it is upper left. B, it is lower right. Okay. So A is clearly lower here, so it is rejected. For this case, now let's think about it. Sorry. If it is A, B, so A is upper left, right? B is lower right. So, okay, so this is a invalid case, my bad. Because this is lower left, this is upper right. Both of these were not correct, right? So this case is entirely rejected. So this case is accepted because where this is the situation. If I do A over here and B over here, this will not work because this is your upper left and this is your lower right, which is not good because A has to be upper left. Then let's come discuss these cases. So here, so this will cater for two vertices. This will cater for the points which are on the x-axis. Okay. And what does it cater for? So there are two ways again. First is place A over here, B over here, and then place B over here and D over here. We can say this is upper left. We can say this is lower right. We cannot say it is left. We can say this is upper right. Oh, sorry, upper left, lower right, which is also both of these are rejected. So here we got a count of 1. Okay. And then what we get here is uh this vertical thing. So here what we get is this, sorry, my bad, this is AB. We can call this upper left, we can call this bottom lower, we can call this lower right as well. This is a correct example. BA, if we go, then this will be lower left or right. Wait, wait. This can be upper or lower, uh, lower left, right? This can be upper right. So A has to be upper left for sure. So this is rejected. B has to be lower right. Oh, so why was this not accepted? So this is accepted. Yeah, this is accepted. Basically, rotate this by 45 degrees and we will get this. Here, this is upper left and this is lower right. We can say that. Yeah, we can definitely say that. Just rotate it uh, another way around by 45 degrees and we get this. And here it is not possible because if we call it lower right and lower right and lower left, it is a red flag because A has an upper identity. So what I noticed here is that, so across all horizontal lines and vertical lines, hmm, if there are X points, so in that case, what we can do is, yeah, note that we don't want anybody in on upon that this line because these are not creating a boundary or so. So that's the case. So let's say there are X points here or X points here. In these cases, we cannot take a jump. We can select like this, and this. So there essentially are 1, 2, 3, 4. Since there were 5 points, so there will be x minus 1 pairs. yeah, if we look at the, yeah, so now let's build the approach. So if I just go to approach building, before that I will have a brief about what this problem is. So in this problem, let me just use an highlighter to explain. Let me use this color. Mhm. This color is fine, right? Yeah. So we have been given 2D points. We have been given coordinates of spots where points can be put, and there are n such spots, and their coordinates are given to us. What we have to do is we have to place n points here. Okay, n points here, n person here, actually not person, n not points, n people here. Each people on one of those n people, n points, place one people at one place. That's easy. But what is the condition among those n people? We have Alice and Bob, and there is a strict condition that these two want some privacy, and for that purpose A wants to be at upper left of a rectangle which they will create. It cannot be a rectangle, then it can be a line segment or something. And A is here, B is A has to be upper left and B has to be bottom right. So this way, and there should be no space, there should be no other node, no other point in this space, then it will be a valid case. So when I examined those cases, I found that, yeah, I found that this is entirely invalid. This case is entirely invalid, which means that in a rectangle, this diagonal is of no use. Okay, so which means that either A or B, the slope, I think I'll come to that later, but yeah, that's the case. So if the diagonal is like this, in that case, we can place it over here. There is one case. If diagonal is like this, yeah, this can also be a diagonal. So here I found that this case is a valid one. This is not. So here if we find 1, here we find 1, and here we find 1. That's it. So these were the valid configurations. So we have to return pair of points where we can place Alice and Bob. Now, before attempting the problem, it's time to go through the test cases to get a complete understanding of the problem. Otherwise, we might miss some approach or input, right? Okay, so what is given in the first example? Let's see that. Uh, I need this. Okay. Okay, so what is given to us? Points which are given to us, the spots which were given to us are these. As I can see that these spots lie on a line like this. And if I go back, in our case, A has to be at upper left. So A can never, so in this case, we found that no possible orientation exists which can have these points placed in a better way. So along this direction, we find 0. So we have 0 over here. It makes sense to me. Now let's go ahead uh, and consider the test case 2. So here, what do we have? We have 3 points, 624426, which we can see here, 624426. These are in a line. I don't think so, but they create something like this. So this case, we observe that there is one possibility, and these two will also form such possibility. So there is one more possibility, and other than that, I don't think we have this cases. So we are fine that there are, wait, yeah, there are two cases here. First is this one where we place Alice and Bob over here. Okay, so this is not a valid one because there's a point in between, but this one and this one are valid ones. So 4 4 is probably here and 6 2 is here. So this one, and 4 4 and 2 6, 4 4 and 2 6 is always here. Okay, now I'm getting some sense of how to solve the problem, but the constraints will tell how we solve it, right? Now let's come to example 3 here. And here what we will be doing is analyzing this. So we have 3 1 1 3 and 1 1. 3 1 is here. 1 3 is here and 1 1 is here. What we are going to do, we are going to do those things. So do we have a line like this where A is at upper left, yeah, and B is at bottom right? Yeah, like this. So yeah, we can fit that such a line here. So I found one very good example over here. And if I undo this, whatever the mess I created, and I will write in a better way, that how did I get this? So here I got 1, and then this line and this line. All of these are valid one, and this will give us 1 1 results as we have seen there. Probably maybe this, not this one, but oh, okay, first analyze this part. So if we go with 1 3 and 3 1 now, what will happen is that the rectangle formed by it, so you see it is actually having this point on the fence, so this is not a valid case. So we have just these two cases where this and this are forming some rectangle. Yeah, so this fence we have to also check. Now if somebody asks about my approach at this point, now we are clear on what's needed. I think all the requirement gathering is done, and this is a really great thing which I have come up with. This part, use some permanent marker and put it like this. First case and second case, basically 1 1 is there, right? And then there is this third case, but here I think there are a lot of cautions. Now we will discuss each of these in detail. So if we have to do this, what we have to find? So we have to reject, first of all, we have to reject this type of lines in the grid. So this is the grid given to us, and we have to reject this kind of lines because they will never be a good one. So we have to reject. Now let's come to this kind of lines. Here we have to accept, but we have to also check for each pair. Definitely we will be selecting pairs like these because I already discussed that we cannot make a jump because there will be a point in between. So in each pair we have to basically create this rectangle and check if any other point lies in between or not. So this part was my understanding. Somebody is messaging me. Okay, so okay, let's do something here. Yeah, okay. So here we have to actually check, for each we have to check if it is a valid one or not. Now we can find a secret, sorry, we can find some logic about filtering that out, but here check is required. So let's say there are x points for uh, I mean x minus 1 pairs. We need that check, and n minus 2 points each, probably something like this. Okay, this is required. So this is the first case. Second case, horizontal lines. So here we are good that we will be getting one, definitely we'll be getting one such rectangle. So if there are x points, we'll have straightforward x minus 1 pairs. All right. Now, same goes for the vertical line. There we don't need to any check. Here, this will be also x minus 1 pairs. Why do we not why do we not need checks? Because obviously there is no boundary, rectangular boundary like these. Okay. Now, so hmm, let's check what will be the time complexity. So here I can clearly see that first find out such lines, such slopes. So what is the difference between this slope and this slope? So that's a good one. How to first identify slopes? Just we just have points. Yeah, let's say we are at point 1 and we go with point 2, point 3, point 4 and keep extending it if you find. Hmm, yeah, so for each point we have to go to Pn. Let's say we used it. Yeah, and then here also the remaining ones we will check. So this is there, I agree. This is itself an order n square approach. First to find out those slopes. And let's say we found out these kind of slopes, then there could be at max across all those slopes, there could be at max n minus, sorry, there could be at max, I think probably n pairs, and for each pair you have to check all other points. That's also a case. Hmm. So which is again n into n, right? So it is an n square. So this entire check is n square. Now here, if I talk about this, so this is covered in this part itself because we can also go vertical, we can also go horizontal, but here we just need order n operation. We are good. This is again order n, so we are good. Now let's go to time complexity. So the complexity which I have came up with is order n square. Now let's see if it is fitting the problem statement requirements. So it well fits because you see these are the constraints at the moment. And what I can do is this. Just give me 1 second, guys. Let me reshare my screen. Okay. Microphone is used by OBS. 1 sec. Okay, so now I'm back. Probably I am audible as well. So let me just reshare my screen. Uh, I am at the same point where I was probably, let me accept this quickly. Yeah, probably I was analyzing time complexity. So I was able to come up with an n square solution. So I believe in my case, this is entirely an implementation problem now. I don't know why. Yeah, it obviously is hard because of this implementation case here. So if I go back to that screen and let's now build the, okay, so the inputs we captured, the requirement gathering we have done, and this is a really important. I must say that this is highly important because this figuring out these cases is really important for this case. And again, definitely this is also very important. Now, how we will do this, that we also again need to figure out. Let me go ahead and build this approach in a code manner. So now, I will use the same space so that problem is next to me so that I don't get uh, distracted by any manner. Let me just delete this. So now we are at the step 3. First was requirement gathering. Second was building the uh, solution approach. And then second was itself checking the solution approach with the constraints and rebuilding it if requirement says you're true. And after that, what we can do, third part is basically converting this logic to code using appropriate data structures so that we don't need to recurrent later on while we go and code. It will be a very, very time taking process if you don't figure out the code logic beforehand. Hmm. Yeah, you might feel from inside that, bro, I have solved the problem. I have solved the problem and I can straight away code it. But when you start coding it, you realize that you missed some of the, you still need to think. You missed out, you skipped a lot of logical building. So yeah, let's come here and discuss the approach. First thing first, my approach, I should write it down. So my approach is this. I will build relationships for each and every point with every other point. What do I mean by this? Is that let's say we start with point 1. We build a slope with point 2, right? We build a slope with point 3. Now it might happen that when I am building a slope with point P4, it came on this line itself. So I'll simply write it over here. Let's call it P4. P4 could be before, P4 could be later on. P4 could be before, P4 could be later. But that also is needed, yeah. That sorting is also needed across this line. So first of all, that is also there. Let me just do this first. So I will build with P1, P2, P3, P4. And what I'll do is that now P2 is analyzed, right? If we analyze P1 and we got P4 and P2 on the same line, which means that P4 and P2 are already analyzed when we complete for this guy. So we will remove it from the iteration set as we list them across any slope. Same way, what we do, we find out the slope of this line and we start putting it. If slope comes out as 0 and infinity, that also will list out. Now once P1 is done, we'll move to the other point which is remaining in the set. Yeah, let's say it is P5, and now we start with the remaining values here. Okay, P5 so let's say we are now operating P5. We'll remove P5 from that set and we then again iterate for P5. The moment we get it, we push it to some set. Okay, that is the case. Now here, when we find out the slope between 2 points, P1, P2, whatever, what we can do is that if it is negative, what should we do that? If it is negative, means how will it look like? Negative slopes look like this. And if it is positive, it will look like this. But we all know that this is a invalid case. So we have to straight away reject it. Straight away reject it. Okay. In case of 0 infinity cases, we don't need further analysis. We can add the values to the answer, right? That we can do. Yeah, and in case of positive ones, we have to handle it differently. Okay. Let's go ahead. This is the approach. Now let's code it up. let's identify the code structure. So I will be using a set where first I push all the points up till Pn. Then next step will be this loop. We can call it while true. We can start at any iterator, right? And for that iterator, first thing we will do is to erase it from the set, because that we are processing now. And then again inside this there will be a while loop. I think one loop will do it all, man. I hope so. So one loop will do what? It will do for P1 and P2, P3 like this. But what about P2 and P3? Yeah, I forgot this. My bad. Wait. So what I'm saying is that for P1 we have n square, for P2 we have n square, P3 we have n square, and likewise for Pn we have n square. Iterations, like solutions. When we add these, the time complexity comes out as n cube. And what is the, sorry, let me just see this. N value of n was 1000 something. Hmm. It was 1000, okay? So it will be like 1000, which is 10 to the power 3 to the power 3, which is 10 to the power 9. So my approach will definitely not work, because we have to kind of bring it down to 10 to the power 7 at worst. If it was 100, it could have worked. But guys, this is really, really scary. Oh my god, how to do this then? I have to sleep as well, right? So, how will we do it? I thought it is just lines, but yeah, there are probably n square such lines. At max, there will be n square lines, because uh, if we select 2 points, uh, if we select 2 points from n points, it is nc2, which is n square. Correct. So n square we can afford. So wait, what I'm saying is that there will be n square pairs, n square slopes, whatever. Makes sense, right? Makes sense to me. Correct. N square pairs will be there in total. Oh, then we are good. Not sure. N square slopes, no. So for each slope, it could go up to n, right? Because for each slope, we have to check if any other points uh, come to that. This part we can optimize a bit. So let's say this is a valid uh, case, right? This upper left, no, this is not upper left. This is a valid case. Positive has to be rejected, okay? This is a valid case. So what we can do is that we can form a boundary like this. Definitely we can do. And a boundary like this. Oh, so this is again a binary search problem. Wow, this is very beautiful, man. Now, if some guy, this is not beautiful, this is crazy. So we have to find it in some some limited time that how many points are here. And then there is some sort of intersection. Really crazy, man, really crazy. We can find if any point is there or not. So in case there is no point, how do we find that out? So for a point, so this is clearly x and x plus delta. And this is y and y plus delta. So we have to find uh, if there are points. So we have xy pairs given. We have to find which pairs x lies between this range, including it, and this is also there here, and y in this range. Man, this is crazy. If we sort by x, if we sort by y, we will get some values. Those values could be, definitely it could be n, but checking out these things that, yeah, what is the time complexity of this check that I need to know? Okay, that I need to know. If we optimize this to log n or something, we will be good at n square log n complexity. Oh, but this is really crazy, really, really crazy. Okay, if we do axis transformation, that is really shittiest thing to do, by the way. N square is okay, but if we do axis transformation, then also what are you saying, man? No, axis transformation is not needed. But how do we know those points are not in this territory? Yeah, I know that the search space will be constricted. So hmm, let's say we have sorted from x equals to 3 to x equals to 5, 8 for that matter, and y is, let's say, 5 to 6, 5 to 7, whatever. So what we will do, we will first, yeah, get into x equals to 3 and x equals to 8. We sorted everything by x, and here we will notice weird things. By the way, this is not sorted, right? Later on this is not sorted, so we might feel that uh, there is some point which is probably x equals to 3 and y equals to, heck yeah. So I'm saying that if it is sorted by the points are sorted by x, it is good. So it is like 3 4, 3 will be there, then 4 will be there, then there will be 5, like this. But it might be the case that 3 is here, and then if we start looking for this y, like if we want to let's say we got this range, and if you want to, yeah, cut this range in a valid value table, it will not be possible because y part is not sorted here. And if we do it in y way, then again this comparison will take order n, so this will not be log n. I think, how can I do this? So my goal is to find out that if this is the line, how to find out that given 2 points, nothing comes in between the rectangle enclosed by them. That's the problem statement. Nothing comes in between the rectangle closed by them. So what should I do then? Well, that is clearly order n, man. That would be n points. Let me think. So these points, if we project, so what is the property? Yeah, this is pure maths. This part is pure mathematics. So we have, how can we filter it out, man? This is really scary. How to know that? Can any pre-computation which we can do? Mm. Any kind of pre-computation if we can do, right? Pre-computation, what kind of pre-computation? That pre-computation could be of, yeah, all the points we, no, we just want an answer. Yeah, if I frame it like this, so we have been given P1, P2, and that those are passed in function, and it tells yes or no. Yes, when yes, if uh, no point in the shaded region, and no if any one point here. So this is the shaded region, bro. This is the shaded region, or log n. Uh, wait, there are n square pairs. Wait, there are n square pairs. Correct, n square pairs are there. To find that out, wait, then it will become very simple, man. My God, Mhm. Okay, so there are n square pairs, right? So while I'm creating these pairs, so essentially this region is, my God, how do we decorate, how do we arrange our point set based on this area? that too very quickly. Wait, when I'm creating those slopes, then I might have created, yeah. So let's think other way around. So let's say if this point X is here, so while I was dealing with this guy, I had definitely created this part, okay? Definitely created this line of slope. So when I had these two slopes together, how can I say that is the case? So wait, let me think of it. Yeah, whatever point lies here that can be joined with this guy, right? So when I am here, what I can do is that I will, yeah, this point is here. So and then there is this point which is outside this boundary scope, correct? So there will be a line connecting each and every point. That line I can get what those lines are. Yeah, that will be the case. Now, oh, I have to check that which of these lines have a limited length. Which of these lines are not colliding with each other? Means they're not affecting each other, coming in each other's area. That we have to do. That how can we do? For each and every point, for each and every, yeah, that will again boil down to the same thing. For each and every slope, we have to do it then. For each and every slope, do the order and kind of analysis. Otherwise, is there any way to know it? That also I have to think. Does it the only way how things could be solved? Mm, okay, let me think of it. I think it's already delayed. It's already late today. So I'll pause this video, continue later on. If you guys are seeing my video, then this is not over yet. I will think about it tomorrow. Is it time? 3